Guys, today I'm going to be talking about the golden ratio and the Fibonacci numbers. And this presentation was made by me, Myron. So, what is the golden ratio, you might ask? The golden ratio, aka 1.61803398875, or just 1.618, is a ratio of the length to the width of a rectangle that looks the most pleasant to the eye. This means that, for example, let's say you're going to buy a TV. You would probably choose the one with the length to width ratio that's closer to the golden ratio, which is 1.618. What this means is, if there's a 6 foot by 5 foot TV, you would rather buy a 5 foot to 3 foot TV instead of a 6 foot to 3 foot TV, because the length to width ratio is closer to 1.618. So, what are the Fibonacci numbers? Well, the Fibonacci numbers are a sequence of numbers that first starts with 1, and the next number in the sequence will be the two numbers before it added together. For example, the first few numbers in the sequence are 1, 2, 3, and 5. And this makes sense because 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, and so on. How is the golden ratio and the Fibonacci numbers related? Well, Fibonacci numbers are actually in the golden ratio, as you could see in the previous picture, which is right here. As you can see on the side here, these are the Fibonacci numbers adding up in the golden spiral, making it bigger and bigger. And so, also, if you would divide two consecutive numbers by each other in the sequence of Fibonacci numbers, it gets closer and closer to golden ratio. What this means is, if you're in the golden ratio, let's say you first do 5 divided by 3, which are two consecutive numbers. And this would equal 1.666 while the 6 is repeating. And if you do the next pair, which is 8 divided by 5, it's 1.6, which is closer to 1.618 than 1.6 repeating. And so the numbers are getting bigger and bigger, which means when divided, they will get closer and closer to the golden ratio. Now, where can the golden ratio be found in nature? Well, sunflower seeds are arranged in a pattern that forms a shape like the golden spiral, which is also the optimal way for packing the seeds in a flower. Also, the outline of the Parthenon at a certain angle also looks like the golden ratio, as the shape of it is pretty similar. Also, a person's ear is actually the golden ratio if you look at it on the side, because it has the right shape. And if you check your own, it would also probably look that way. And lastly, a nautilus shell is the same type of spiral as a golden spiral, because it's small in the middle and then it gradually gets bigger, just like the golden spiral in the previous few pictures. So, who invented the golden ratio? Experts are still not sure how the golden ratio was invented, but they are sure that Euclid was a person who invented the golden ratio, and he had invented it at around 300 BC, while Leonardo Fibonacci was the one who came out with the Fibonacci numbers at around 1200 AD, which is about 800 years ago. Where can the golden ratio be found in art? The golden ratio can be found in the Mona Lisa, because in this picture, as you can see, if you check her face, it would have the golden ratio at around this part. And then it keeps going just like on her body. And then this could also be seen in the outline of the golden spiral in the previous slides. Right here, as you can see, it has the shape right here, which looks pretty similar to a spiral. And so now, here are some fun facts about the Fibonacci sequence in the golden ratio. If you multiply any 3 consecutive numbers in the Fibonacci sequence, and you multiply the first and third numbers, then you square the second number. Unless you subtract the bigger one by the smaller one, it will always equal 1. For example, if you choose 1, 2, and 3 as the 3 numbers, 1 times 3 is 3, 2 times 2 is 4, 4 minus 3 is 1. And this works for any other 3 consecutive numbers if you do it that way. Also, every third number in the Fibonacci sequence is an even number, which means it's a multiple of 2. Every fourth number is a multiple of 3, which means it's divisible by 3 as well. And every fifth number is a multiple of 5, so it's divisible by 5. Lastly, the golden ratio could be both in squares or spirals. Thank you for listening to my audio. Bye.